right, you guys, this is our last set of video notes for this unit, and we're going to talk about 1-6, solving absolute value inequalities. Today, we're going to solve inequalities that are absolute value and graph them on a number line using those vocabulary words and or. Let's get started. So we're going to first remind ourselves on what absolute value means and how to graph it on a number line. Remember, absolute value needs to be isolated, and then we take our two cases. So case 1 was our positive case. I would get rid of the absolute values brackets and then have less than 6. I would just keep my same sign. On case 2, my negative case, we need to be a little bit more careful because what's going to happen is two things. I'm going to change my sign and make it negative. Remember, whereas before we just made that negative, now we're going to change our sign and make it negative. So let's see how that looks on our number line. We're going to put 6 and negative 6. Of course, the smallest is first. Watch our inequality. For negative 6, it is an open circle, and it says greater than, so going to the right. Okay, I'm just going to shade a little bit to kind of see what happens with that 6. For this 6, again, open circle, and it says less than 6. So it's going to shade in the middle. Remember when we talked about and or? This one would be an and type inequality because it's graphed in the middle. Next up, for letter B, we're going to take our two cases. Case 1, positive case. Get rid of my absolute value braces. X is greater than 3. For case 2, we're again going to get rid of those absolute value braces, but we have to remember to do two things. Flip my inequality sign and make it negative. So let's see how that graphs. I'm going to graph this one. X is greater than 3. Put 3 on our number line, put negative 3 on our number line. X is greater than 3. Open circle. Greater than is to the right. Then X is less than negative 3. Open circle to the left. You might have figured it by now, but this is what or would look like. Let's look at letter C. This one's kind of interesting to me because it says the absolute value of X is less than negative 3. If we remember something about absolute value, it's that absolute value can't be negative. And this one is asking us to make it less than a negative number. That's not possible. This is no solution. There's not even a way to graph this. For letter D, let's see what happens. The absolute value of X is greater than negative 2. That is something that is definitely possible. We can have an absolute value that's greater than a negative number. So let's see how that would work out. Let's take our two cases. For case 1, our positive case, I would say X is greater than negative 2. For case 2, my negative case, I'm going to say X, flip that sign, is less than negative 2. What happens if I have negative? A double negative is a positive, so positive 2. And I also flip that sign. So let's see how we would graph it. I have negative 2, and I have positive 2. For negative 2, it would be open circle, and it says greater than, so to the right. For case 2, it says less than, so open circle, and to the left, so again in the middle. This is, again, and. It's kind of hard to really tell what they would be until we graph them. Let's look here. This is a general rule of thumb that comes in handy. It says great or, so like if you think of greater than, greater, or for greater, And look at how this absolute value inequality looks. I have my absolute value and a greater sign and then C. And this is how my OR would be graphed. And then for less than or less and, this is how I would write my solution set. So let's see. Let's do a couple of examples together. For this first one, it says 1 minus 3 times the absolute value of 6y minus 5 is less than or equal to negative 11. So first off, I'm going to look at this and remember to myself, I need to isolate that absolute value before I can start. So let's start by subtracting 1. So I have negative 3, absolute value, 6y minus 5 is less than or equal to negative 12. I still need to continue working on isolating, so I'm going to do the inverse operation and divide by negative 3. I'm left with the absolute value of 6y minus 5 is less than or equal to, wait a minute. If I divide by a negative number, what needs to happen to my sign? I need to flip it. So I have just divided by negative 3, so I need to make sure to flip that around like that. Let's continue. So I'm going to take my two cases from here. Case 1, my positive case, 6y minus 5 is greater than or equal to 4. And let's solve it. Inverse operations, 6y is greater than or equal to 9. Y is greater than or equal to 9 over 6, but of course if you can reduce, you should, so 3 over 2. Case 2, let's check it out. My negative case, 6y minus 5. Let's watch my sign here. I have to flip my sign on my negative case. Less than or equal to negative 4. And let's continue. Add 5 to both sides. 6y is less than or equal to 1 minute. All right, let's continue. So negative 4 plus 5 is 1. And let's go ahead and finish solving that. Divide by 6 on both sides because that's the inverse operation. Y is less than or equal to 1 over 6. So I'm going to graph these two fractions on my number line. 3 over 2 is improper, so I know that that's bigger than 1 over 6. So 3 over 2 and then 1 over 6. Let's go ahead and finish this up. If I'm looking at the 1/6, that has a less than or equal to sign. So I know it's going to be a filled in circle, shaded to the left. And then 3 over 2, again, it has greater than or equal to, so a filled in circle, it's closed to the right. So this would be a OR type inequality. And see, just from looking at the beginning, you might say, oh, less and, but in reality, when I worked it out and isolated that absolute value, it was a greater or, great or, okay? So keep that in mind. You have to isolate first. Moving on, solve the absolute value inequality and graph on a number line. So let's try this one. Subtract 3 on both sides. Always isolate the absolute value before trying to solve. So from here I can take my two cases. Case 1. Alright, so to work on case 1, we're going to get rid of our absolute value brackets. Negative 9n minus 3 is less than 3. And let's solve it. I'm adding 3 to both sides. I get negative 9n is less than 0. Sorry, 6. 3 plus 3 is 6, not 0. So now that we're here, let's just go ahead and finish it. Divide by negative 9, but what happens on an inequality if I divide by negative? You got it, flip that sign. And let's go ahead and reduce that fraction to 2/3. Let's try case 2. So for case 2, again, get rid of the brackets, but sorry about the bells, guys. Don't forget, when you do case 2, flip your inequality and change the sign. So flip it and change it to -3. So let's solve. Add 3 to both sides. -9n is greater than, this one is 0. And I'm going to divide by -9. So n, I did divide by a negative. I'm going to flip my sign, but it's still 0. So let's see how that looks on a number line. I'm going to have -2/3, and I'm going to have 0. They both do not have an equal to, so I'm just going to have my open circles. So n is greater than -2/3, so that's to the right. N is less than 0. So these face inwards. This is a and type inequality. Less and. All right, last example that we're going to do together. Solve the absolute value inequality and graph on a number line. Let's go ahead and get through this. First, isolate that absolute value. So divide by 4. So I'm left with the absolute value of 6 minus 2a is less than or equal to 4. Let's take our two cases. For case 1, the positive case, 6 minus 2a is less than or equal to 4. So solve it. Move the 6. Move your constant before you divide, so that's -2. Look at what I'm doing here. I'm dividing by negative, so don't forget to flip that sign. And let's do case 2. The negative case, 6 minus 2a. Flip that sign whenever you have your negative case. And then solve. -6. Sorry, this should be negative right there. So -6. So -2a is greater than or equal to -10. Divide by -2. Be careful to note that I am dividing by a negative. So again, flip that sign. Let's mark our number line with 1 and 5. So a is greater than or equal to 1. So it's going to be solid and to the right. And a is less than or equal to 5. So solid and to the left. Again, this is a and type inequality. All right, you guys, let me know if you have any questions. See you tomorrow.